Becoming an AI engineer in 2026 doesn't take years. It took me 3 to 4 months to learn AI and land my first job building prediction models for the stock market. Since then, I've built AI for Apple Vision Pro, self-driving cars, and I have multiple AI patents. Companies like Apple, Google, Meta, Netflix headhunt me for AI positions, and I don't even apply. I'm going to show you the exact roadmap to become an AI engineer as fast as possible. 4 phases: foundation, working with models, building real systems, and getting hired. Let's get into it. So what exactly is AI engineering? It's not data science, so you're not actually doing heavy math and learning like calculus and statistics and back propagation and grading, things like that. So you're not actually training the models. You're actually going to be working with the models that are already pre-built. So you're not building them from scratch, and you're not research chasing, looking for the latest benchmark or the latest papers, the state of the art, and trying to beat those benchmarks. What you're actually doing is working with real world data. Actually, like in my case, I worked with messy financial data sets to get a real world results. And you're going to be using like Python as pretty much an automation core for scripts and pipelines. But even though at the end, you don't even need to use coding if you don't have to. Knowing it and knowing how all these things work will actually make you a much better AI engineer. But the actual job itself, these things are already done for you, and you just put them all together. So you're really taking the research that's been done in here and actually bring it to production. That is the value of an AI engineer. You want to take the papers and actually use it to usable code and actually bring this business value and actually impact to the business. So here's the roadmap. Phase 1, the foundation. Python is non-negotiable. You should learn how it works. You don't necessarily have to use it in actual code, but the thing is, if you do know how it works and how to code, it actually makes you better and it makes you a lot more valuable. All AI tools are built on it nowadays in terms of the convention being used. In the past, ML, you can actually build machine learning neural networks with any language, but the de facto is Python and PyTorch at the moment, so any paper will actually use it. The other thing is, you want to learn just in time. Learn what you need to actually get the job done. For example, if you're going to go to a new country and you don't know the language, you're going to learn enough to get by, or even just being immersed in it for 2 weeks. You learn what's a common language to get by, to actually solve your problems of like saying hello, getting to places, interacting with people. You want to solve the problem in front of you. You're going to do the same thing when you learn. Once you know the foundations, you want to learn what you need to get by. The other thing is you want to know like the core Python focus. In general, the data structures, loops, functions, how files are work, what's JSON, CVS, which is basically common separated values, or think of it as Excel that you could put it out into a text format, APIs, application programming interfaces. And you want to know the basic data science stack. This is data science stack that is used in Python, which pure Python is not as strong or as fast as like C or C++, but if you use something like NumPy for numerical calculations, Pandas for things like Excel sheets, and Matplotlib to visualize the data so you can explain it to non-technical people and the stakeholders so they can make a decision. These are common tool sets that you need to learn. And the other thing as well for the foundations, learning Git from day one. Basically, it's learning how to source control, how to write your code and keep track of it and keep up to date. You basically look track of the changes. And if something goes wrong, you could always revert back. Learning this Git and the Git workflow is extremely helpful. It's actually how professionals work with it. You need to learn how to do this. And basically, when you're learning, there's actually no hardware barriers like it was in the past, because if you have a Gmail account or a Google account, you might know that you could go into your Gmail and you could actually create a Google Doc. You could also like create like a Google Sheet. So Google Doc is like, it's the free version, Google's free version of Microsoft Word, and also like Google Sheets is like the free version of Microsoft Excel. But you could actually create other things. You might not see it right away, but usually there's like a 3 dots, you can click on it, and there's another thing called Google Colab or Google Collaboratory, and that allows you to code in Python, and it even gives you access to GPU, so you can do even heavy duty calculations for free on GPU. And all this can be done in Google's platform. So all you need is the internet. You don't need to buy like a beefy like gaming computer and spend thousands of dollars. If you have the internet, you could do it. You probably even do it on your mobile device, like an iPad, for example. Phase 2 to the roadmap is actually working with models. So you want to learn pretty much like the prompt engineering fundamentals. So if you go into ChatGPT, how to ask questions, what to give clear instructions, context examples. If you want to understand how to use it, a general idea is think of it as if it's an assistant and you're asking the assistant to do something that you normally would do, but you're giving them the instructions so they can do it on your behalf. That's one way to think of like how you could do prompt engineering. So you could give them the direction and tell them what is the clear instruction, what is the context, what are examples of what success look like, and what is a format you want as output. You want to communicate simply, so pretty much like at a 4th grade explanation level, so it's easier for anyone to understand. Not everyone studied the subject matter to your degree. The main thing is to be able to communicate to other people that are not subject matter experts or SMEs for that, right? And you want to configure it for the business needs. That's where the context comes in, right? You want to show the desired outcomes and outputs, and the desired outputs and the constraints that, for example, you have a certain time limit. There's only a certain amount of hours of the day, or certain resources available, or capital available, or money. And the other thing is you want to be able to use like model APIs in actual code. So again, there are tools where you could actually build everything without coding, but if you know how to do this, you make yourself 10x more powerful, which means that you become more profitable, more valuable. Companies will come out to you and you could actually ask for more money. So learning how to do Python requests and get responses, this is why in phase 1 you want to learn the Python basics, and so you could actually up your level. And the other thing as well is the trade-off is that if you're using pre-made models, it's going to cost tokens. Basically call it tokens, but you're going to pay for tokens, and you have to be aware that the prompts you're using or the models that you're using to make predictions or make Python requests with APIs and whatnot, how much it costs. So you want to know also the keys, what's the limit, what's the usage per day, per month, how much it costs. And the company needs to be aware of it because the return on investment has to be much greater than the cost of doing all these things. But you have to factor all those in. And the other thing as well, there's other options where you don't necessarily have to pay with tokens. There are open source models, and there's platforms such as Hugging Face, or you can even do local control where you could actually install it on your own local computer instead of using the cloud. Hugging Face is pretty much like the GitHub, but for models. Now, the thing is you have to be aware of, though, is that if you're using open source models, either they might not be as powerful as commercial ones, mainly because of the implementation might not have been trained on data itself. But you could, if you've done the foundational and you learned with models here, you could actually take those and train it and fine tune that to make it specific with the data for the company, so you can make it more powerful than even a commercial model, possibly. And you could host it on-prem or on-premises or local computers, so you don't have to pay for tokens. But being aware of how to do all this stuff is a skill set. And the other thing with open source models, you have to pay attention to the licenses to see how you could use it, can use it commercially. If you do, maybe you could use a model, but you can't use the data. So you have to be careful with that. Even with with paid models as well, you have to see how does it deal with data, because data security is always an issue. So those are things that you want to look into with the legal team and with the company, and what are your resources to make that work. Phase 3 is building real systems. You want to go from demos or like toy projects that you see in like tutorials to actual real systems that are applicable, that solves real business needs that will actually be valuable to them. And you want to show the multi-step workflow, like how do you curate the data? How do you get it? How do you clean the data? How do you find insights on it? How do you build a model off of that? And how do you interpret that data and actually show it and give recommendations to the stakeholders and explain that and visualize that data to non-technical people and for them to make informed decisions. Think of it as if you ever watch Star Trek Next Generation with Captain Jean-Luc Picard, anytime there's a major decision, he makes a final say, but he asks the different people in different departments on his crew their opinion from their expertise and their recommendation based on what they know, so he can make a final decision. That's what you're going to be doing with that. The other thing as well, now LangChain orchestration, basically LangChain, learning to deal with LLMs or large language models in Python, and like the tool sets will be Python and JavaScript, and how to deal with that with memory, nowadays this is a skill set you should learn. And as well, what made major advancement in recently for models to have such better performance, because it was hallucinating and make up things a lot, is the RAG architecture. How could it take real world data to incorporate and pull from, instead of, if it doesn't know, it will make it up? And then dealing with embeddings and vector databases, how that works. The other thing, especially if you're working with companies, and I get attest to this because I see this a lot with projects and contracts I've done, where companies want to integrate their data, their internal docs of decades of information they have that is scattered all over the place, and also even information where people that created it might not even be there anymore, but it's still relevant. But they live somewhere in internal docs, PDFs, databases, consolidate all that, and that's accessible when they need it at their fingertips. And the other thing that also augments AI engineering and AI models and whatnot is that they're not great at everything. They're optimized. Let's say an LLM is a large language model. It's great for a specific context that's just trained for that. But you might think if you ask it a simple math question, it might seem like it knows what it's doing, but when you look at it, a lot of times just even simple math questions, it could get it incorrectly because it wasn't trained to deal with logic for math specifically. But now with agents, what it could actually do is take other programs to solve that problem, get the results, and give it back to them. For example, you could use a calculator to solve the math problem, get the results, give it back to the LLM to output the actual result, or use like a programming language like Python or NumPy within it to make something more complicated. And you could create more agents to do specific things like OCR, which is like optical character recognition. So it could basically give it a picture of words and it can figure out the words on it. That's very valuable to actual models, and it's a skill set. So learning how that agentic workflow works, deal with APIs, databases that exist, and other workflows that already exist for the company. And pretty much the LLM or large language models, their operations life cycle, right? You want to be able to create it, monitor, make sure it's working, optimizing it, and when it's actually working in production, and deploy it. How do you train a new version, deploy it, and sunset or retire an old version and keep training and keep that cycle? You want to be able to understand how that works and how to suggest that for a company. Now, here's phase 4. How do you actually get hired? So the main thing, portfolio over credentials. Show that you work with real messy data in real projects, such as, for example, if you're dealing with retail company, something in the retail space, and they have a POS, like a point of sales, that's where they actually take the money and keep track of it. And the thing is about that, in real world data over the years might have different formats for, let's say, the date. Some of them might format it as day, month, year. Other might be year, month, date, or month, day, year. They have different formats. There's no standardized way that's universal how to show the date. Now, if you take the date as is and try to process it in any model, it's not going to give the right result. So you want to show how do you pre-process, how do you curate the data, meaning get it, and then process it to standardize it, how you deal with missing data, and to actually put it into a model to make it work. You want to show that. That's very, very important. That's one of the biggest things that's missing in the difference between tutorial data and when you work in the real world. That's one of the biggest things. And then we want to show strong end-to-end builds, including different workflows like RAG and agents. Like I mentioned, RAG is actually training it with real data with additional information. So it could actually pull from agents where you could have other programs to do things that the model might not be strong at. For example, math, you might bring in a model that actually do calculations, like a calculator, or a programming language that could do more sophisticated calculations, or other specific workflows that there might be out there that you want to integrate. And the main thing is you want to prove the business impact. This is going to be your headline of why you should hire you and what you bring to the table. And you want to basically showcase or highlight the time saved, either and cost reduced or costs that you've gained or capital gain that they make by using your solution. You want to show before what did it look like before your solution and after, and you want to show clear, measurable, tangible results that are much better than what it was, that is actually going to have an impact for their business. And the other thing is you want to market your results publicly, and you want to show them like on LinkedIn, on Twitter, where you have real solutions to real problems that companies are looking for. The other thing is when you start when you start applying for jobs to get higher, apply early and target domains that you know that you can actually solve. Your background in that domain is going to be an advantage because you know what success is supposed to look like in that space. For example, I might know AI engineering, but I might not know, let's say, the food industry. That's not my space. So even I would have to learn how that works. But if you're already in that space and you worked in it for years and you know what the pain points are and what the solution's supposed to look like and what people will be excited for, the impact, you're going to be extremely valuable than someone that just knows AI just in general. Here, I'm going to give you my honest truth. The roadmap, it only works if you actually do it. There's over the years, I had a lot of people ask me how things that I've worked with, and they've seen the end results and they're like, hey, I would like to do this. And I spent time, hours, literally hours, writing out emails, telling them step by step what they need to do. And in almost all the cases, they never even did step one, right? The thing is, execution beats knowledge. Just going on YouTube and watching videos all day long, I mean, you become a little more knowledgeable of the field, but no one's going to hire you. They want to see end results, something tangible. So you need to execute. Even if you're 10 times more knowledgeable than someone else, but that person executed on something, who do you think they're going to hire, right? And the other thing that makes it hard is staying consistent. At first, you might feel motivated, it's good. The hard part is going through it and staying disciplined and consistent. And that is the main challenge, because when you start out, especially at the beginning, there's no rewards early. There's no feedback. It's going to seem non-deterministic, where you do a lot of work and it seems like you're getting nothing back, right? It's going to take time before all of a sudden things work out. That is one reason why we say start applying early while you're learning, because when things start lining up, it takes a while for it to work, but it seems to fall into place out of nowhere. But no, it just accumulated. The main thing, you have to basically stay consistent, and you actually have to get the work done for it to work, right? The other thing that makes it really, really hard is comfort kills urgency, right? And I could say this in almost all cases, is that if you're comfortable in your certain spot, if you already make, a decent living, you're comfortable with your job, you're happy to a certain extent, you could say, okay, well, it's hard to stay consistent, because you'll wake up one day and you might not be motivated and you don't want to be disciplined. You're like, okay, well, I don't have to learn it today. I could just skip today. Well, how's that going to hurt, right? Well, the main thing about that is that one day starts to 2-3 days, and then you never get back to it, right? The main thing is why deadlines work and is because there's urgency to it, right? Is that if you don't do it by this time, then something will happen and something unfavorable to you will happen. And that is the main thing. So the thing is, if you're comfortable, you risk delaying your learning on it, right? And the main thing is, the main people that I know that are able to be, the people that I know that are successful in things, even if they're comfortable where they are, they know where they want to be. They'll create urgency for themselves. And I know one person that I admire greatly, because I've seen them do it, where they're already comfortable and they'll just cut it off, and they're like, no, they go to the extreme. This has to be done. I'm going to go and create urgency, because I know at this point in time, I need these things in place for it to work. And if I don't do this now, that's not going to work, right? And the other thing about it is, it's extremely hard. It's just human nature, not just in this field, and just in general, right? That's why people get with groups, to have people who are like-minded, that understand your goals and will help you out and that helps you with accountability and finding other peers in that space who are trying to do the same thing. So when you don't feel motivated and they're like, hey, you need to get this done because this is the goal you wanted to achieve at the end, they'll keep you accountable for that, right? And the other thing is, when you start off, you're not going to hit a home run on your first swing. You're not going to hit it on your 100th swing, most likely. Maybe not 1,000, right? But here's the thing. One win changes everything. You could fail 1,000 times, but once you succeed one time, all those rejections that you apply for jobs before, it becomes irrelevant because you got a job. It doesn't matter. Everyone forgets about that. Main thing I want to stress above all, start now and solve real problems.